This time we have a particle that moves along the x-axis so that its velocity is given by this function. Not its position, but its velocity is given by v of t is equal to 3t squared minus 12t plus 9 for the first 5 seconds. And the first thing that's asked is how many times did the particle change direction? I think that in order to answer that, it's best to look at the graph of v of t. And we know this is quadratic. If we factor everything out, we could look at v of t as being 3 times x minus 1 times x minus 3. And just from that, we've got enough to come up with a good graph. Like, this thing definitely has x-intercepts at 1 and 3. It's a parabola that's going to open up like this. Now, back to the first question, how many times did the particle change direction? Well, on this first interval from 0 till 1, the velocity is positive. At 1, the velocity is 0, so that means it stopped. And over the next interval, from 1 to 3, the velocity is negative. So this velocity went from being positive to being negative, stopping at 1. That's one time that it changed direction. Then the velocity changed from being negative to being positive. That means that it went from moving to the left, it stopped, and moved to the right. So how many times did the particle change direction? Twice. And that's at both of these x-intercepts. Next, I asked for 3 different integrals, and you could find these integrals by hand, or you can find them on your graphing calculator. Either way is fine with me right now. But for C, we want to find the integral from 0 to 1 of the velocity function. And from 0 to 1 means that we're going to find the area under the curve here from 0 to 1. Calculating that gives us a value of 4. Next, we go from 1 to 3 and find the area under this curve. Well, since this area is underneath the x-axis, that will give us a value that's negative. And you should find out that that value would be negative 4. After that, from 3 till 5, it means we're going to find this area. And this one is going to have a value of 20. So if I didn't take the time to actually calculate all of those integrals by hand, what's the point of having these in this question? Well, first of all, knowing those three values allows us to find the overall integral. So we said the area of this section was 4, and the area underneath here was -4. After that, we had this area to be 20. So in order to find the integral that starts at 0 and goes all the way to 5, that means we're finding the overall area from 0 all the way till 5. And all we have to do is add these together. Of course, the 4 and the -4 are going to cancel out, which means that this integral from 0 to 5 is going to have a value of 20. But what does it mean? Well, we know that if we take the derivative of the position, we get velocity. What I want to point out is that if I take the integral then of velocity, what we're getting is a change in position. Okay. So the position changed over these 5 seconds by 20 units. So in part G, when I say that after 5 seconds the particle was 17 units to the right, where was it when it started? Well, over those 5 seconds, it moved a positive 20 units. So where did it start? 20 units behind this 17. So its start was at -3, or 3 units to the left of the origin. Now for the very last part, I do ask, overall, the particle traveled how many units in total? Well, remember that it started at this -3, and first it had a positive velocity, which gave us a positive distance traveled, those 4 units. After that, it moved to the left 4 units, but it still traveled 4 more units. And then after that, it went to the right again, another 20 units. So in total, it traveled 28 units altogether.